Hello dear students of class 10th. Here we are going to start the next topic, that is conservation of energy. Dear, we have studied various types of energy, various forms of energy in the previous lectures, and we have done lots of numerical over there. Now I am going to move on the topic that is called conservation of energy. Conservation means, first you have to understand what do you mean by conservation. Conservation means there is no change in that amount, whatever will be. It means if you have 11 rupees in your pocket and you go to the market, you have buy something and come to at your home, and somehow you return what you have right now. Perhaps, let an example. You go to market and you have 11 rupees and you go to the market of 5 rupees you have taken a chocolate. Okay? Remaining 6 rupees you have. So, again you return to home. What you get? What you have still now? You have 6 rupees and a chocolate of 5 rupees. Okay? It means now again you have a value of 11 rupees. Okay? It means your 5 rupees has changed its form in the form of chocolate. I hope you are able to understand here. It remains again 11 rupees because you have replaced your 5 rupees by taking a chocolate. Okay, so I hope you are able to understand the meaning of conservation here. Okay, same way, the meaning of conservation I am making to you understand in physics. Okay, according to the principle of conservation of energy, energy can neither be created nor can it be destroyed. It only changes from one form to another form. Means, dear, if you are working, you have energy. If you are working where you feel tired, why? Where that energy goes? That energy you have lost. You have that energy you have given to some other body. But the energy you have, and you have some parts of you given to another one, but it not destroyed. It had changed from one form to another form. Here in the whole universe, the total sum of energy, whatever be the form, total sum of energy is constant. It is just changing from one form to another form. Okay? So I hope you are able to understand whatever is the format of energy, that is light energy, heat energy, frictional, all work done. Okay, whatever is the format of energy, electrical energy, mechanical energy, these all sums of energy remains constant in this universe. So just to grant you that it is confirmed that the sum of many forms of energy remains constant, let us going and taking an example of mechanical energy to prove theoretically that sum of kinetic energy and potential energy means total of mechanical energy always remains constant. Totals of electrical energy will read in a higher class remains constant. Okay, whatever the format of electrical energy will provide to a rotating fan. Okay, and how much its mechanical energy produced and how much energy is wasted. These all sum are constant. Okay, in the higher class you will also taught nuclear energy, and there you will be also what be theoretically explain the conservation of energy. Okay, so here I am going to start with a theoretical explanation of conservation of energy by taking in consideration of mechanical energy. Okay, if there only one interchange between the potential energy and kinetic energy, the total mechanical energy remains constant. That is K for kinetic energy and U for potential energy. Sum of kinetic energy and potential energy remains constant. Means whatever be the phase, the condition will be, the energy will be same. Let us take an example. Let's suppose here is the ground. Here is the ground, and you are releasing a body of mass m from some height h. You are releasing, okay, some height h. There is a body having mass m at some height h, okay dear, from the ground surface. I am just releasing it, okay, from point, let's consider that from point A. It will start moving downward, it will reach to somewhere in the mid. Let's say that point is B. Again it will, before striking, it will be here, anywhere, before striking the surface. Okay, let's, that point is C. Means if a ball is falling from some height to the ground surface, let's suppose that the height of ball from the ground is h. It is moving to some distance in the mid, that point is B. From A to B it will reach, and then it will strike the ground. Okay, before striking a point there is a C. Okay, so I hope you understand this consideration. Now come to point A. Come to the point A. Case 1, or it may simple. Let's add the energy at E. Okay, the energy at A. Here is only one energy present over the ball, that is potential energy, because body at A, at the position of A, is stationary. Just you are holding it, just you are releasing it, so its velocity is, initial velocity is 0. Okay, so the potential energy of body is mgh at point A. Okay, it will be mgh. Okay dear, because it is above the height h, it has the mass m, and g is the acceleration due to gravity. Now come to the point kinetic energy. I am writing in short. Kinetic energy of body at A. Okay, that is half mv square. It means there is a d 0, that is u. We may also take u square also. So half m0 square, it means 0. Kinetic energy becomes 0. The total energy at A will be kinetic energy plus potential energy. Simply, so that will be equal to mgh plus g. Means total energy. Let's say that I am writing here total energy at A will be mgh plus 0, that is mgh. Okay. So if the ball start moving from point A and it will go down, and move down, and it will reach to point B. Here at A, initial velocity is 0. When it starts falling, its velocity go on increasing and increasing. When reaching at point B, let's suppose that its velocity become v1. Let's suppose that its velocity become v1. Okay? Or you may also take vb. I am taking 1. It will be easy for you. Okay? So what is v1? v1 is the velocity of a body which is falling from point A to point B. Okay? Let's suppose that while going from A to B, it has traveled a distance of x. It has traveled a distance of x. Okay? And the remaining distance is h minus x. Okay? From B to C. If it has traveled a distance h from A to B, the total distance is h. So remaining distance will be h minus x. Okay? So now we will find energy at B. Energy at position B. So simply we have to find out first potential energy at B. Right now I am writing it so potential energy at B. Substitute. There is a below that B means position. Potential P for potential energy at B. Potential energy at B will be mgh B. I am saying that hb means height of the object, height of the body from the ground to point B, that is hb. Yes, hb is equal to h minus x. As it has moved x from up to point B to reach at point B, so the remaining distance from the ground it will be h minus x, that is h minus x. mg hb I am putting value, that is h minus x. So mg h minus mg x. This is the potential energy of a body at point B. Now I am going to find kinetic energy of body at point B. Means kinetic energy of body at point B is equal to 1 upon 2 mv1 square. So there is a problem. How we will find v1? It is easy, dear. Okay, so you all know about the equation of motion, Newton's equation of motion, the three equation of motion, that is v is equal to u plus at. Okay, v square is equal to u square plus 2gh, and so here I am writing we have a three equation, that is v is equal to u plus at. You may take gt. V square is equal to u square plus 2gh. Okay, and the second equation is, that is, so we will use this equation here. V square is equal to u square plus 2gh. Okay, dear. So I am going to use this formula. I did not, because dear, here there is no time. It is not given their time. That's why we are not going to use the first equation. So it is not Okay dear? So V1 square is equal to 2gx. So dear, we have done the value of V1 we have. V1 square we have. Okay? So kinetic energy at B will be half into mass of the body M into V1 square. Value of V1 square is here 2gx. Okay dear? So 2 will cancel out. mgx kinetic energy. That's it. The total energy at point B, total energy of the body, at point B will be kinetic energy at B plus potential energy at B here. So kinetic energy of body and potential. You may also write that kinetic energy at B plus potential energy at B. I will also write it like this. So it will be same as mgx plus potential energy mgh minus mgh minus plus it will cancel out mgh. The need energy is mgh. So I hope you are able to understand here. The total energy at B is mgh. The total energy at A is mgh. Okay, total energy at B is mgh. Total energy at A is mgh. So there is only what? Conversion. There is only conversion over here. That some energy has changed from potential energy to kinetic energy. Though the sum total of potential energy and kinetic energy is same here. Let us take another example, that is potential energy at C. So I say you that the whole sum, whole change is always constant at everywhere. Okay? So now come to the point. Potential energy at C. Okay dear, as point C is almost near to the ground, means slightly above, means just height of C from the ground is 0. Height of C from the ground is 0. Consider it. Here your assumption should be the height of point C from the ground is 0, means point C and ground are slightly in touch, in contact. Okay, so there potential energy will be 0. So mgh should be taken 0. So it will be 0. Now come to kinetic energy. Kinetic energy at C will be half mv square. Let's say v2 square. Let's suppose that before striking the object velocity, before striking the ground, just it is near, it is slightly in contact. Before striking, the velocity of object will be v2. Let's suppose that. Then find out v2. v2 is simply find out this formula. V square is equal to U square plus 2gh. Okay dear? So final velocity is v2. Initial velocity is 0. After traveling a distance of h, 2gh. So final velocity is v2 square is equal to 2gh. By putting the value of this half m v2 square means value of v2 square is 2gh, means there is only one energy per convergent at C, that is kinetic energy, and that is equal to mgh. Means here the sum total of total energy, PE I am writing for total energy at point C, that is kinetic energy at C plus potential energy at C. The sum total is what? mgh plus 0, that is mgh. Okay here. So I hope that on 3 points the sum total of energy is mgh. Whatever be the condition, though object was rest at the point A and it has 0 value, so there is one potential energy. Okay, that is mgh. At point B, object was in motion. At point B, object was in motion and it is decreasing its height. So, as it is decreasing its height, its potential energy decreases, and the energy, the conversion of that potential energy into what? Kinetic energy. Means half of the energy it has converted into kinetic energy. That's why sum total of potential and kinetic is mgh. At point C, there is a no height. There is a no height. Means it is slightly in contact. So it is near about. That's why potential energy is 0. While kinetic energy is mgh. It means whole total of potential energy at point A has converted into kinetic energy at point C there, and the sum total is again remains same, mgh. That's why we say that energy can neither be created nor destroyed. I hope you are able to understand here. Now I am going to explain you this phenomenon through a pendulum. Okay? Just I am rubbing it. Okay dear? May I rub it? I hope I see you. So please understand it. Oh, before moving to the pendulum, come to the graph. Okay. Let's suppose there is a graph between potential energy and kinetic energy. Okay. So total energy, potential energy and kinetic energy. I am making a graph of this. Okay here. When body is at some height, mgh, its potential energy means total energy. I'm just explaining by drawing it. This graph is between distance and energy. Distance means how much distance the body, how much above the surface of the ground the body is. Okay. Let's suppose that body was at a height h, so distance is represented h here. Okay. When the body was at height h, its potential energy was mgh. When the body was at height h, its potential energy was mgh. Like suppose you observe from here. Okay, at that time potential energy was mgh. But when the distance is decreasing, as the distance is decreasing here, half. I have got the diagram half. its potential energy has converted into kinetic energy, and the potential energy remained 1 by 2 mgh here. Okay, when the body reaches to point C, means at a 0 distance from the Earth's surface, its kinetic energy has become mgh. Its kinetic energy has become mgh. I hope you are able to understand this. When the body was at above, there is no kinetic energy, only there is a potential energy which is just decreasing on the decrease of height of the body, as the diagram says. On the decrease of height of the body, the potential energy decreases while the kinetic energy increases. Okay, so I hope you are able to understand this diagram. Now I am coming to the conservation of energy through pendulum. Okay, first of all, understand what is pendulum. Dear, pendulum is a system, okay, in which a thread is tied with a mass in. Okay, this mass is called ball. Okay, when this body is moved from its mean position, this position is called its mean position. It is moved to some distance. Okay, some distance. Okay, let's draw a origin. If you are applying some force to bring it here from position A to position B, the body will rise up to height. Let's suppose that this height is h here. So if body is here, there is no kinetic energy, no potential energy. Okay, if you pull this body to point B or point A, let's suppose that if you pull it to point B, it will rise above by h. So there will be increase in potential energy. If you release this body from here, it will not stop here, it will move to here. Why so? Because it is due to conservation of energy here. You have given some energy by making the body, moving the body from their mean position to extreme position. From their mean position to extreme position, you have increased the potential energy here. So potential energy at B is mgh. Let's suppose that mass of the bob is m and height of the bob at B is mgh. There is no kinetic energy here because you have releasing this body from here. There is no kinetic energy over here. Okay, so because body is in rest here over the point B and point A, the velocity of body will be 0. So kinetic energy at B will be 0. That's half mv square. V will be 0. Half mv square means so V is 0. That's why it will be 0. Okay. By adding, we will get mgh. But when the body will move to point A, there will be no potential energy because its height will decrease to 0. Height at A will be 0. That's why the potential energy at A will become 0. dear, and kinetic energy at A will become half mv². Okay, dear. So velocity of body at A will be, according to conservation of energy, the total energy at B will be equal to total energy at A. So kinetic energy at A is equal to total energy at total energy at A. You may also write it as total energy at A is equal to total energy at B. So dear, half mvp VA square, because kinetic energy is 0, the total energy is this will be only kinetic energy. So potential energy at this point will be 0. So it has only kinetic energy over there, and total energy at B will be mgh. So velocity at m will be cancelled out. Velocity at A will be equal to 2gh. It means velocity at A is equal to root under 2gh. I hope you will be able to understand here. If you have any problem, please ask me during the class. Okay, thank you. Bye.